Class 1 and Class 3 are classifications within a system used to designate the suitability of electrical equipment for hazardous locations where flammable materials are present. Class 1 refers to hazardous locations containing flammable gases or vapors in the air. Class 3 designates hazardous locations containing easily ignitable fibers or flyings. Equipment rated for Class 1 Division 1 is designed to be intrinsically safe. This means that it cannot ignite a flammable atmosphere under normal or abnormal operating conditions. Because of this high level of safety, equipment rated for Class 1 Division 1 is also considered safe for use in Class 3 environments, which inherently pose a lower risk of ignition compared to the presence of flammable gases and vapors. To confirm this rating, the user manual or technical specifications for the equipment should indicate its Class 3 rating. Alternatively, the manual may provide a statement confirming its suitability for Class 3 locations based on its Class 1 Division 1 rating. For example, the equipment documentation might state, "This equipment is rated for Class 1 Division 1, Groups A, B, C, and D, as well as Class 3. Intrinsically safe equipment, designated as Class 1 Division 1, employs design principles that limit electrical and thermal energy to levels below those required to ignite a specific hazardous atmospheric mixture. This is achieved through various methods, including current limiting, voltage limiting, and power limiting techniques. The goal is to ensure that even under fault conditions, the equipment cannot produce a spark or generate a surface temperature sufficient to cause ignition. In Class 1 environments, the hazards arise from the presence of flammable gases or vapors that can mix with air to create potentially explosive atmospheres. These atmospheres are further categorized into groups, such as Group A, Group B, Group C, and Group D, based on the specific type of flammable substance present. Each group requires equipment with specific design features to prevent ignition. Class 3 hazardous locations, on the other hand, involve the presence of easily ignitable fibers or flyings. These materials, such as cotton, wood, or plastic dust, can accumulate and pose a fire hazard if exposed to a sufficient ignition source. While the ignition risk in Class 3 locations is generally considered lower than in Class 1 locations, it is still essential to use equipment that is designed to minimize the risk of ignition. The National Electrical Code, or NEC, provides detailed guidelines and requirements for electrical equipment used in hazardous locations. The NEC specifies the types of protection methods that are suitable for different classes, divisions, and groups of hazardous locations. These protection methods include intrinsic safety, explosion-proof enclosures, purged and pressurized enclosures, and other techniques designed to prevent ignition. When selecting electrical equipment for use in hazardous locations, it is crucial to carefully consider the specific requirements of the location and to choose equipment that is appropriately rated and certified. The equipment should be clearly marked with its class, division, and group rating, as well as any other relevant information. It is also essential to follow all applicable installation and maintenance procedures to ensure that the equipment continues to provide the intended level of protection. In addition to the NEC, other standards and regulations may apply to electrical equipment used in hazardous locations, depending on the specific industry and application. These standards may address issues such as equipment design, testing, certification, and maintenance. It is important to be familiar with all applicable requirements and to ensure that all equipment is in compliance. The selection of appropriate electrical equipment for hazardous locations is a critical aspect of workplace safety. By understanding the different classes, divisions, and groups of hazardous locations, and by choosing equipment that is appropriately rated and certified, it is possible to minimize the risk of ignition and to create a safe working environment. Remember to always consult the user manual or technical specifications for any equipment used in hazardous locations to verify its suitability for the specific application. The manual will provide detailed information about the equipment's ratings, limitations, and installation requirements. It is also important to follow all applicable safety procedures and to receive proper training before working in hazardous locations. For example, an intrinsically safe circuit is designed to limit the energy, both electrical and thermal, to a level below that required to ignite a specific hazardous atmospheric mixture. This is typically achieved by limiting the voltage and current in the circuit to safe levels. There are various methods employed to achieve intrinsic safety, including current-limiting resistors, Zener diodes, and intrinsically safe transformers. These components are designed to limit the energy in the circuit even under fault conditions such as a short circuit or open circuit. Intrinsically safe equipment is typically tested and certified by a third party to ensure that it meets the applicable safety standards. The certification mark indicates that the equipment has been evaluated and found to be safe for use in the specified hazardous location. When installing intrinsically safe equipment, it is important to follow the manufacturer's instructions carefully. The wiring and grounding of the equipment must be done in accordance with the applicable codes and standards. It is also important to ensure that the equipment is properly maintained and inspected on a regular basis. Another method of protection used in hazardous locations is explosion-proof enclosures. These enclosures are designed to contain any explosion that may occur within the enclosure and to prevent the propagation of the explosion to the surrounding atmosphere. Explosion-proof enclosures are typically made of heavy-duty materials such as cast iron or steel. The enclosure is designed with tight-fitting joints and seals to prevent the escape of flammable gases or vapors. Explosion-proof equipment is typically used in locations where there is a high risk of explosion, such as in chemical plants or refineries. When selecting explosion-proof equipment, it is important to consider the specific hazardous materials that are present in the location. The equipment must be rated for the specific group of hazardous materials that are present. It is also important to ensure that the equipment is properly installed and maintained. Another method of protection used in hazardous locations is purged and pressurized enclosures. These enclosures are designed to prevent the entry of flammable gases or vapors into the enclosure by maintaining a positive pressure of clean air or inert gas inside the enclosure. Purged and pressurized enclosures are typically used in locations where it is not practical or feasible to use other methods of protection. The enclosure is designed with a system of filters and seals to prevent the entry of contaminants. The pressure inside the enclosure is maintained by a fan or blower. Purged and pressurized equipment is typically used in locations where there is a moderate risk of explosion, such as in paint booths or printing plants. When selecting purged and pressurized equipment, it is important to consider the specific hazardous materials that are present in a location. The equipment must be rated for the specific group of hazardous materials that are present. It is also important to ensure that the equipment is properly installed and maintained. In summary, understanding hazardous location ratings and selecting the appropriate electrical equipment are critical for workplace safety. By following the guidelines and requirements of the NEC and other applicable standards, it is possible to minimize the risk of ignition and to create a safe working environment. Always consult the user manual or technical specifications for any equipment used in hazardous locations to verify its suitability for the specific application. Remember to follow all applicable safety procedures and to receive proper training before working in hazardous locations. Equipment suitable for Class 1 Division 1 locations inherently meets the safety requirements for Class 3 locations. This is because Class 1 Division 1 standards demand a high level of protection against ignition sources due to the presence of flammable gases or vapors. The design and testing required for Class 1 Division 1 certification ensure that the equipment cannot generate sparks or excessive heat, even under fault conditions. Since Class 3 locations involve easily ignitable fibers or flyings, the level of protection afforded by Class 1 Division 1 equipment is more than adequate. Always verify the equipment's suitability by checking the manufacturer's documentation, which should explicitly state its Class 3 compliance or its suitability for Class 3 environments based on its Class 1 Division 1 rating.